So, in this section of stuff, just a reminder, you guys have a quiz on Wednesday, on 7.1 to 7.3, and there is evidently a sample quiz posted. Didn't know I did that. Because I don't normally give a quiz in this unit. But the calculus, the work in this is in the setup, and the AP exam will often say set up, but don't evaluate it, just set it up. Please follow the directions. Those of you who spend a lot of time evaluating, it's unfortunate. So the first one, find the intersection points if you did not have a calculator. Hopefully that was fine because that's just algebra. And you could have solved for, gotten the y values first, you could have done a number of things. The next piece, graph them. And that should be not a challenge, it's just a straight line and a parabola. You guys are okay with those, despite your excuses on geometry? Okay. All right, so area between the curves. Right minus left, top minus bottom, which one would we do? Tell me, one did you do?
Top minus bottom.
Okay, so what would that be?
From negative 2 to 0, 3 minus x squared minus 2x plus 3.
Okay. And right minus left would have been a big pain because you got to find the equation of the left side of the square root, which was a negative. But questions or issues with that? Okay. I need to show you guys today's stuff. Was the homework super crazy? Issues? These just set up. Find a formula for the cross sections, and that's all they actually asked for. They didn't even ask you to integrate or set up an integral. But this is the example that we did a few things from last week. Using that equation, depends on the orientation. Perpendicular to the x-axis, so going this way. Do we have dx slices or dy slices? Dx. So I need y equals all the jumping terms of x. Solving for y. Plus or minus. And the top curve is the positive. This bottom curve is the negative. So the diameter is the positive 1 minus the negative 1, which is also known as twice that square root. But that's the diameter. I only wanted half of that. So the radius is just that square root. And that squared is something nice and pretty. Yeah.
When it asks you to find like the cross sections, does that mean you're just supposed to find the area of the cross section, the formula for the area, or?
Yeah, so this is asking you for a formula for the area. Because once you find the formula for the area, that's your equation, and then you need to figure out what bounds. And this is a circle, so all the bounds were -1 to 1, whether you're doing it with respect to x or with respect to y. And it would be easier if you just doubled it and integrated from 2 to 1, 0 to 1, because it's symmetric. So they didn't actually ask you to do the integration, they just wanted you to find area formulas. Were there questions on stuff? This one is the stinker that made a big point of the 30, 60, 90s last week. Well, this is the hypotenuse of a 45, 45, 90. If I tell you that diagonal is 8, how do I find the length of the side? Luke, what were you going to say?
Divide by root 2.
Divide by root 2 because geometry, 45, 45, 90, or pi over 4, pi over 4, pi over 2. And the ratios work. Hypotenuse to hypotenuse equals leg to leg. Put this backwards. So divide by root 2 and it's 4 root 2. Okay, we need to spin things today. So, solids of revolution, why do we need to know this? Things in engines, things that move often spin. So, if we take this weird shape and spin it around an axis, we end up getting this bottle shape or this funnel or whatever. Okay. We did this a little, I mentioned it last week. You have a rectangle and you spin it, what shape do we get? Circle, and if there's any thickness to it, it's actually a cylinder, right? So, just like the Play-Doh problems, we're gonna find the area of the cross section. If it's a thing spinning around a stick, what's the area formula we need? The area of a circle, so it's always gonna be pi r squared. Dx or dy is going to happen as well. And then you just integrate over whatever bounds they want. So it could be fun shapes. Could be. But the formula for it is just pi r squared, where r is going to be an equation, not just a number. So I want to show you something. So again, the 3-dimensionals are hard to visualize. So there's a weird slice of a parabola. If I spin it around the red line, can you guys visualize what it would look like? Any description? What do you think? It's going to spin around the red line.
Like a funnel cake.
Like a funnel cake.
Like inside.
Okay. Miriam, what would
Like
you,
a platter, or like a
Like
dish I could put like a cake on or something.
like a skinny pedestal and then going to a fat one to hold a fat cake? Okay, well, let's look. So I like the cake analogy. Whoops, I turned it the wrong way. Holding a cake. Oh, I lost the 3Dness. Okay, so we're gonna find the volumes of that kind of stuff because that's fun. Oops. Too far. Alright, so our first problem. We're gonna find the solid, a spinning back thing. And you probably don't exactly know what square root of sine x looks like. You can guess, right? Like you know where it's 0. Brooke, where does sine equal 0?
I can't do this on the spot.
Okay.
0 pi.
0 pi? Okay. And sine, Camden, what sines, the y values that come out of sine?
It's like 1, 2,
What's, okay, what's the highest y value that comes out of sine? 1? Okay. Sasha, sine 0 to pi, is it always positive or does it cross the x-axis?
Always positive.
Always positive. I don't know exactly what square root of sine looks like, but what's the square root of 1? 1. So this is gonna look kind of like a sine curve arch. Might be a little steeper, might be a little flatter, but it's gonna look kind of like that. Alex, where did it say we're gonna spin? Around what axis?
the x-axis.
On these problems, I like to put little loopy arrows so that I know which way I'm going. Because they will often ask you part A, B, C, and D, spin it this way, spin it this way, spin it these other ways. And you're gonna need to keep that straight. So Grady, the slices, are they dx slices or dy slices? Dx. All right, so I need the area of a cross section. Gabe, the area of the cross section, circle. So what's the area of a circle with that radius?
Pi times sine squared, or sine x.
Pi times square root of sine squared, which is, yeah, just sine x. Okay, so there's my cross section. Now, what do I set up to find the area of this weird looking football thing, rugby ball?
We kind of got it from 0 to pi.
Integrating from 0 to pi. Josh, integral of positive signs.
Negative cosine.
Okay, negative pi times cosine of pi is negative 1, cosine of 0 is positive 1. So what's it come out to be? 2 pi? I think these are easier than the Plato problems because the equation's always just a circle. And as long as you know the circle equation for the area is pi r squared, not the circumference one that I will not say. but not very long. Yeah.
Like, how much work do you have to show? Because for this one, if I just use like the formula that you gave, you pull out the pi, and then the square root of sine x squared is just sine x. Would you have to formally write out the areas equal to that, or can you just go into it?
I always do in the land of, like, if you went straight from here to there with no picture and no area of cross section,
You're not showing me to understand.
well, really, the reason I ask you guys to show work is you'll make less mistakes when you clearly label things. And on the AP exam, when I have to grade these, there's often 1 point for showing the area and 1 point for getting the integral. If you skip this step, but you did it right here, they will give you that point for this kind of question. But if you did it wrong here and used that incorrect thing here, you would get this point, not that one. But if you just started with this, you would get neither. If that makes any sense. So if you said, my area is pi sine squared, that's wrong. But if you correctly used your wrong area, if they understood that you were like, this is what I thought the area equation was, and then tried to integrate that, they would give credit here for that 1 point, not there. So there's some partial credit they can give you if you show more stuff. Okay. This one's weird. We're not finding the area between the curves, finding the volume. Stuff is fun. As many skins. It becomes every slice is a circle. So I'm making out. There's an issue. This is floating in the air. So find the volume of the solid form by revolving 2 minus x squared, all right. And y equals 1. First of all, you need to be careful. What space are they talking about? And it's just that little snoot up here, because it says the line y equals 1 and the curve 2 minus x squared. Those two things, they make that little ovally shape. And they want you to spin it around bless you, y equals 1. So Sophie, here's, I'd be like, y'all need to show me something here. What is the radius of the circle going to be? Sorry? 1. Is this, the radius is 1 right here, but is the radius 1 here? The one that, no, so I need an equation, okay?
2 minus x squared minus 1.
So top curve, 2 minus x squared, minus the bottom curve, or the line that we're spinning around, which is 1. Some clever children always say, oh, this confuses me, can I just move the whole picture down and spin it around the x-axis? And make this be y equals 1 minus x squared, and then spin that. And that's what we did. So sure, if that's how you see this. All right, that's my radius. I do not have the area equation yet. Nina, what would the area formula for the circle cross section be?
1 minus x squared squared times pi.
1 minus x squared times pi. Okay, so the volume that we're finding is going to be that cross section integrated from what to what? I didn't find the intersection points. Tom, what would they be?
Negative 1 to 1, but you can just do 2 times from 0.
How do I integrate that thing inside there? Do what? Chain rule? So if I raise the power, divide by the new power, and then divide by the stuff inside, I don't have an x.
Distribute first, so it's like 1 minus 2x squared plus 4, or plus x squared.
Multiply it out so that you can just do 3 different undo a power rule. Third plus 1/5. What do you guys get? Massimo, did you get an answer?
I got 4 pi.
4 pi over 5, because 1/3 plus 1/5, 5/15 plus 3/15, 8/15, 16. I get 16 over 15 pi. Fraction. Crazy? Spinning? John, what do you think? Good? Resting? Good morning. Monday. All right. Draw the picture. Set up the equation. Yeah. 16 over 15 times. I think I messed up on the basic portion. Okay. Do you have the same starting number? Yeah, I have it. Oh, you negative 1 mark. All right. So
One bed. So,
Minus
650 times 2. 850.
It's. That's going to positive 2/3 and 1/3 negative 1 So when possible, yeah. So you have 2 4/3.
Yeah. Yeah, okay.
So I did it, I got you, yeah. Okay, thank you.
That's why. So positive. Yeah, no, I think it was the only reason. Because plug in 0 for x, positive. So it's like.
Is that the shape that we're spinning? Is this weird, like, hook? X equals -1, this vertical line is what we're spinning around. Y equals 3 is the top. And then this curve. When y is 0, x is -1. When y is 3, x is 8. And it's a parabola-y thing. Why am I not taking the bottom?
It's not about that.
No, I mean, it needs to touch 3 lines.
It's not touching y equals 3.
It's not touching the y equals 3. So it's gonna be this kind of weird fat funnel. Do I have dy slices or dx slices? What? Which way are the circles going? What are the thickness? dy. And the y values are going to go from 0 to 3. And I need pi r squared. So please. Hadley, what's the radius?
Like y squared minus 1 minus 1. Or minus negative.
So the distance from this green line to this is the right, which is y squared minus 1 minus the left, minus -1. So that's actually adding. Simplified pretty nicely. So I'm just integrating y to the 4th. Yeah. And here's the most common problem. I just did it. What's missing? What's wrong? Drop pi. 243/5 times 5 times, what's the question? Yeah, 81 times 3. I didn't know either, I was like, wait. Think about that. Okay,
Is the radius always the right equation, not the left equation?
okay, the radius is always the distance from the outside curve to the stick you're spinning around. So, top minus bottom or right minus left, and not, this next thing is, because you said something. This is not on the quiz, but it's on the test. If that first problem we did, this guy, if we're not spinning around that actual stick, if I'm spinning around here, I gotta do something else. I need to find, it's gonna be like a weird donut with, yeah. But I need to subtract out, there's a hole in it, I need to drill a hole. What we're doing today is called disc method, because this is solid. Like, it's spinning around and has space, like stuff colored in up to that stick. This thing's gonna make a hole. That's not on the quiz, but it will be on the test. Okay. So, really, did you guys have any questions about the Play-Doh problems? I made Play-Doh yesterday. I brought Play-Doh if you need to look at it. Or, I don't know. What was the equation we just did? Oh. Fun.
A blue crust.
I don't know what I've just done, but. Okay, start. 1 to 9 odd. Sorry, I'm not finding the homework that is for tonight. Oh, that one's the stinker. To 9. Oh well, I can't find my homework. Well, Yeah,
I started yesterday at like 5.
13 to 19.
Yeah. Oh, okay. Yeah. Well, I didn't get home till 5, and then I did one till 5:30. I know. So I was, it was fine. 4 hours sleep. But it's fine. I'm like used to it now.
Okay, guys, there's your whole 5 problems. 13 to 19 odd, so 13, 15, 17, 19, 4 problems.